Alright, so most of you probably know these kind of flashlights. They work by mechanically converting the input motion to a quicker one, which generates electricity by rotating a conductor coil between a couple of magnets. Whee! Now, that got me thinking. What if you use the rotation of the output shaft to drive a fan instead of a motor? To basically have a fan to cool you off in the summer that doesn't need electricity and is running on clean energy. As long as you have a plant-based diet. It will be a handheld device, so the gears need to be quite small to fit in there. Another challenge of this project will be getting the gear ratio just right and to keep the fan continuously running in one direction, although this piece moves in both directions. Okay, so let's go to the drawing board and come up with the design. I'm not going to go into detail on what went wrong with the first few versions, but I basically was still figuring out tolerances, gear ratios, and how the individual shafts connect to gears. At first I wanted the shafts to be tightly attached to the gears and freely rotating in the case. Then I did the opposite and let the gears rotate around the shafts, which turned out equally as bad. My final solution was a compromise between the two, based on what I had learned from my prototypes. The moving gear is attached to the shaft, while the others are only being held in place by it. We'll get to why it's moving in a second, but first let me tell you about my first semi-success in this project. On version 4 or so, the mechanism was finally working, but it was not producing the results I wanted. First of all, it wasn't moving any air to the front, but rather pushed it all out the sides. Turns out you need a lot more air to be able to flow to the back of the fan, and the small gap between fan and housing just wasn't enough. I then made two versions with holes for airflow, and this one worked the best by far. Another thing that I kept having problems with were the first two gears. They kept skipping and shearing their teeth off when I was exerting too much force. So I made the teeth a lot stronger, and I couldn't get them to skip anymore. This exposed new failure points. I had to replace the integrated pivot with a new one that has metal reinforcement. Sounds fancier than it actually is, I just put a screw in it. Also at some point, the lever broke, but it was mostly a printer fault because I was under extruding, which made for a weaker part. I still reinforced it in CAD to prevent this happening again, and had to cut out parts of the case to make the new one fit in. You bet I wasn't going to print another one. But now that it's working smoothly, let me show you what the moving gear is for. It's allowed to move freely on two axes, because it needs to disengage with the next gear when the lever is pulled back to its original position by the spring. Now, that's about it. But unlike the mechanical flashlights, you can't really generate electricity with this. Or can you?